The bias field signal is a smooth, low-frequency signal that can cause image intensity variations in an MRI image, as seen in the original MRI image on the left. This bias field, seen in the center, can be caused by RF inhomogeneities and cause problems for image processing algorithms such as skull stripping, registration, and segmentation, resulting in unsatisfactory results. Therefore, there is generally a need to remove the bias field as part of processing structural MRI data. An example of a bias field corrected image is shown here on the far right. There are multiple tools available for bias field correction. One of the more popular tools is N4 bias field correction. Before we try typing N4 bias field correction into the terminal, we will need to again install this tool as it is not part of FSL. To install, please run the following commands. After the installation completes, try typing N4 bias field correction into your terminal. You should see a printout and a brief description of what N4 bias correction does, as well as how to use it. It should be noted that this is not part of FSL, but the usage is very similar to FSL-based commands. A typical command uses N4 bias field correction like so. First, specify N4 bias field correction, -D3, which stands for the dimension of the image, and we are typically using three-dimensional images, -I, and followed by the path to the input image, -O, followed by a path to the output image. Now try removing the bias field from the nifty image that you just created using DCM to NIIX using the following commands. Open both the original image and bias field corrected image with FSL eyes. Take a screenshot of these images to include in the lab report. What differences do you notice with the bias corrected image compared to the original brain image? After running the bias field correction on the image, we will move on to brain extraction. The purpose of brain extraction is exactly what it says, to extract the brain and remove the majority of non-brain structures such as the skull, eyes, and neck. This is really considered a preparation step for image registration and segmentations, as the skull and other non-brain structures can influence and cause problems with these registration and segmentation steps. FSL has a very easy tool to use called BET, for extracting the brain. Type BET into the terminal. Here you will see a list of different options that are available. Also, the FSL wiki and user guide provides extensive information about how to use the BET tool. Check that out if you would like to see how each of these options and how they might be used. Now try to run BET on the bias field corrected image that you just created. For example, you could use the following command. Alternatively, one could first CD into the subjects directory and specify the command using relative paths. This will create the brain extracted image, and based on the example that we have here, the image will be called brainimage_bias_bet.nai.gz. Using FSL eyes, open the brain extracted or skull stripped image and take a screenshot to include in your lab report.